Hello all, today let's solve this LeetCode question, kth closest points to origin, right? So first let's try to read the question and try to understand what they're asking. So here they're saying, given an array of points where points of I mean any point in any index is in this format, which is x comma y. So it actually represents a point on the xy plane and an integer k. Return the k closest points to the origin 0, 0. All right. So what they're asking us to do is they'll be giving us a graph like this. So this is an x-axis and y-axis graph, and we'll be given some random points here, right? So you can see a point here. This is in the format x comma y, and there is another random point here which is again in the format x comma y. What they're asking us to do is they're asking us to find the k closest points to the origin. So origin is obviously this point which is 0 comma 0, right? So now how are we supposed to find the distance between these 2 points? So for that they have given this. So the distance between 2 points on the xy plane is the Euclidean distance, which is nothing but a square root of x1 minus x2 whole square plus y1 minus y2 whole square. So we would have seen this formula in our high school maths, right? So we need to find the distance of every points from the origin, and we need to return those points which are closest to this origin, right? So for example, in this graph, there are 2 points, and they're asking us to find one point which is very much close to the origin. So obviously from this graph, we know that minus 2 comma 2, which is this point, is closest to the origin, and this point which is 1 comma 3 is little bit far from the origin compared to this point. So we just need to find the k closest points to the origin. That's all we need to do. And they have also mentioned that we can return the answer in any order, and the answer is guaranteed to be unique except for the order that it is in. All right, so we can just return the answer in any order. So hope the question is clear. So before jumping into coding, let's try to think of an intuition here. So whenever you see questions like this, find the k closest points, find the kth smallest point, find the kth largest point. If you see any questions like that, you should directly think about using priority queues in Java. Okay. So what priority queues are is they have an internal data structure called as min heap. All right, so they always maintain either the smallest number in the top or the largest number in the top. As and when you pull messages from the queue kind of assembles or reheapifies, so that the smallest number is always in the top or the largest number is always on the top. It's up to you. By default, priority queue implements min heap, which means only the smallest number will be in the top. But then if you can override the priority queue to implement a max heap, which means only the largest number will be in the top. So that is the data structure we are going to use now. So before jumping into coding, let's try to understand this with one more example. So let's say we have points like this. Let's say we have 1 comma 2, and then let's say we have 9 comma 9, and then let's say we have 2 comma 2, and then let's say we have points 8 comma 9, for example. Okay, and let's say we want to find the two closest points to the origin. So if this is the input, obviously you know that 1 comma 1 and 2 comma 2 are very much close to the origin, whereas 9 comma 9 and 8 comma 9 are not closest to the origin. So here we want to find the first 2 points which are very much close to the origin. So obviously it is 1 comma 1 and 2 comma 2, right? So now how are we going to get these two values out of the input array, right? So now if you look at this method signature, they are asking us to return an integer array, which means array of integers. So basically your response should look something like this, which is nothing but 1 comma 1 comma 2 comma 2, right? So your response should be array of array. So they have given a 2D array, and your response should also be a 2D array. So now how do I find this? So let's say I know that 1 comma 1 is closest to the origin and 2 comma 2 is closest to the origin, but now I need to get these values from the input array, right? Because this is present somewhere and this is present somewhere. It need not be that this is in a sorted way or anything like that. So the points that we need could be scattered, or it could be present anywhere in the input array. So we need to know the exact location of these values, right? So for that purpose we'll be using an index. So I know that 1 comma 0 is present in index 0, right? I know it's present in index 0, and 2 comma 2 is present in index 2. So we have to prepare our priority queue in such a way that both these values and the index are maintained. Okay, only then, whenever I find the closest distance, I will be able to look up on this index and get the value that I want to return. So this is the whole idea, guys. But as and when I implement the code, it will make more sense, right? So first, let's do this. So create a uh, let me create a queue. As I mentioned, we'll be using queue for this. So I'll use queue, and I'll use an integer array. Okay, queue is equals to new priority queue. Okay, so why am I using an integer array? So this integer array will have values like this. So the first value will be index. Okay, and the second value will be distance. So my every integer array will have will have the value index in index 0, and will have the value distance in index 1. So as soon as I find this closest distance, I will look up on this index and grab the value that I need. All right. So here I need to sort this queue based on the distance, right? So I want to find the points which are closest to the distance. So this distance is present in index 1. So what I'll be doing is I'll be asking my priority queue to sort based on the distance. So what I'll do integer dot compare. I'll say a of 1 comma b of 1. That's it. So uh, why I'm using index 1? Because in index 1 I'm going to have my distance. Okay, and index 0 will just have the index. All right. Okay, so before adding my elements into the queue, I will have a helper method to get the distance, right? So let's say private int, I'll say get distance, and this will accept four values. So int x1, int y1, int x2, int y2. As you can see, to find the distance, we need to use this formula, which is x1 minus x2 whole square plus y1 minus y2 whole square. But here, I am not going to do the square root here. I am just going to do this formula, x1 minus x2 whole square plus y1 minus y2 whole square. I am not going to determine the square root. Why am I not going to determine the square root? The logic is very simple. If I know that value 2 is less than 5, then obviously I can say that square root of 2 will be less than square root of 5, right? If 2 is less than 5, then square root of 2 is also less than square root of 5. I don't need to find the exact square root to do the comparison. If I know that 2 is less than 5, then I know for sure that square root of 2 is also less than square root of 5. So I'm not going to do the square root, get that value in a double or float, and make it messy. We'll just keep it simple with primitive int itself, right? All right. So now let's try to do this formula here. So we have, let's say, x diff. I'll just say which is x1 minus x2, and then let's say we have y diff is nothing but y1 minus y2, right? And then finally we have to return this, which is x1 minus x2 whole square is y1 minus y2 whole square, right? So I'll do which is x diff cross x diff. So I need to find the square, right? So x1 minus x2 is already found here. Now I need to do the square. So that's why I'm doing x diff cross x diff plus y diff cross y diff. All right. So our helper method is ready. Now let's try to loop over the input and add all the elements to the queue. All right. So for int I equals to 0, I less than points dot length I plus plus. As you can see, this queue accepts an integer array as the input, right? So I'll be initializing an array here. Integer array equals new int, and the size of this array will be 2, right? As you can see from this example, the size is 2. The index 0 is nothing but the index of the input element, and the distance is nothing but the distance between the current point and the origin, right? So now I'll do array of 0 equals to index. So we need the 0th index to be the actual index. So I'm just initializing that here. And array of 1 will be nothing but your distance. So how do I find the distance? I already have the helper method here to get the distance. So I'm just going to call the helper method, get distance. So what is x1 minus x2 and y1 minus y2, right? So you can see the points of I is x1 and y1, right? So what you have here, we have points of 0. So this is going to be my x1, right? And my y1 is going to be points of 1, and my x2 is going to be 0, and my y2 is going to be 0, right? Okay, I think I am doing it in the other way around. It should be something like this: points of 0, and it should be points of 1 and I. So this is actually int x1, and yeah, this is y1. Let me recheck this once. X1 minus x2. I think we are right. I think it should be like this. Okay, let's see. Anyways, if I made some mistake here, we will rectify it. Okay, I'm just trying to map the correct value to the correct method variable here, right? So when I do x1 minus x2, it will take points of 0 and this guy, and y1 minus y2 will take points of 1 and this guy. All right. All right, okay, so we have prepared this array, and then all we need to do is just add the array here. That's it. So now the queue will take care of sorting the arrays based on the distance, because that's what we have instructed here in the comparator. Okay, now we have to just return the response. My response is again an array of array. So what I'm going to do is I'm going to uh, initialize result new int of k, because we need to return the k closest point, so that I'm initializing my result with size of k. All right. So now what I'll do is for int I equals to 0, I less than k, I plus plus, and result of I is nothing but your top element, right? So q dot poll will give you the smallest element which is present in the top of your queue, but I need to return the actual array, not the index, right? So how do I know? Uh, how do I get the actual value? We already have the index and distance mapping here. So what I'll do, I'll just pass 0, which will give me the index, and with the index, I'll get the actual value which is present in points. That's it. That's it, simple. And then finally we return the result. All right, let's try to run this. Cannot be converted to int. Okay, let's see what is happening. Points of 0 and points of 1. Okay, all right. I think we made a mistake here. So we are iterating a 2D array, not a single array. So let's say int point is nothing but your points of I, and then you just do the point here. All right. Okay, the answer got, our code got compiled. Let's try to submit this. All right, the code is accepted. So this is it, guys. So let me reiterate once for the last time. So we need to find the closest closest points to the origin, k closest points to the origin. So whenever you see any questions to find the kth smallest, kth largest, or anything like that, always think of a priority queue. And since we need to find the closest points to the origin, we need to sort our queue based on a criteria. So here the criteria is nothing but the distance, which is this formula. So I just pass that criteria as a comparator here, which always sorts your elements based on the distance. And yeah, and then you just use this formula to find the distance between the points and the origin. You keep on adding them into the queue. And as I mentioned earlier, all the smallest points will be present in the top. So yeah, so whenever you do a queue dot poll, it always picks up the topmost element, which is going to be your smallest element. And since we need the actual element and not the index, we have this kind of mapping here. So every array will have the index and the distance for that particular point. All right, thanks guys, bye bye.